Hi everyone, welcome to this lecture. So in this lecture, we are going to solve our project 2 on KNN classifier. So basically in this project, we are going to learn how to find the optimal value of K in order to perform the KNN classification. So here I am inside my KNN folder and this is my project 2 which is inside my KNN folder. Let's click on this file so that we can open it in our Google Colab environment. So here I am in my project 2. So for project 2, I need pandas, I need matplotlib, I need kfold. Basically, I am also going to perform grid search cross validation for KNN in this project as well. Therefore, I need a kfold, I need grid search cross validation, I need train test split, I need k neighbors classifier, and I also need a function make_blob in order to create the dataset. Let's run this cell in order to import all these necessary Python libraries. So I have imported all these libraries. Now I am creating a dataset. Here I am again going to create the challenging dataset with 3 labels and with standard deviation is equals to 3.5. I have 1000 samples. I have 2 features. So let's run this cell to create the data. Here I can see the shape of my data. My features especially, which is 1000 by 2. So I have 1000 samples with 2 features. Okay, and how many unique labels? So I have 3 classes, 0, 1, and 2. Here I can visualize my data. So this is my data visualization. We can see that we have 1000 samples divided into 3 labels. We have class 0, which is of red color. We have class 1 in blue color, and we have class 2 in green color. So we have 3 classes basically labeled as 0, 1, and 2. So this is the scatter plot of my data. Now I am splitting the data into testing and training component. I am using 20% of my data as a testing. It means remaining 80% will be used as a training. So let's run this cell to split the data. Here I am standardizing the data. Here I am standardizing my training component of the data. And here I am standardizing my testing component of a data. Let's run this cell to standardize the data. Now it's time to visualizing the testing data. So if I want to visualize the test data, we can see that there are quite a few number of samples which are mixing, especially for class 0 and for class 1. Okay, now it's time to apply KNN classifier. So if I run this cell, I will be able to instantiate the KNN classifier. If you see here, I did not pass any number of nearest neighbor. So I did not pass any input parameter or any number of a nearest neighbor. Let's see what is the default value. So in order to check the default value, I have to pass this function k neighbors classifier into the help function. So I have to call a help function on k neighbors classifier. On my k neighbors classifier, it's not a regressor. We need a classifier. Okay, so let's run this cell. And we have to also, okay. So let's run this cell to call the help function. Okay, let's scroll up. So we can see this is k neighbors classifier and the default value is 5. So basically this KNN classifier is using 5 neighbors in order to classify the test data. So this is the default value which we have been using from the project 1. Okay, let's start with the default value. Let's uncommit this so that I can save the space. Okay, so it means when I instantiate k neighbor classifier, the number of neighbors are 5 here. Okay, here I am fitting my model to the training component. That is, I am training my model on the training component. And here I am getting the prediction from the testing component. Okay, now I have the predictions by the model. I compare the predictions of the model with actual test label so that I can calculate the accuracy. And we can see that this is the accuracy 92.5%. So this is the same accuracy which we obtained in project 1 for this challenging dataset. And now we can visualize the predictions. So we can see that these are the data visualization. These are the predicted data by the model. So we can see that there are quite a few misclassification. That's why accuracy is 92.5%. Now we have to improve this accuracy. In order to improve this accuracy, we have to find the optimal value of k. Now we are not going to use the default value of k, which is 5. So we see in the document of KNN classifier, that is the default value of k, which is called nearest neighbor, is 5. Now, how to find the optimal value of k? In order to find the optimal value of k, we have to use error rate plot. What is error rate? So error rate is the difference between the 100% accuracy or the actual accuracy. Basically, it is the difference that how accuracy or how much accuracy is far apart from being 100%. Suppose the accuracy is 90%. In that case, the error rate will be 10%. If accuracy is 99%, in that case, error rate will be 1%. So it is the difference between the 100% value for the accuracy and the actual value of the accuracy. Okay, let's plot the error rate in order to find the optimal value of k. So the first step is that we set the empty list for the error rate. Here I am running a for loop for 30 different values of the neighbors. Okay, for 30 different value of the neighbors, I will select that value of k which will have the lowest value of the error rate. Okay, so here I am instantiating my classifier. This is k neighbors classifier. Here I am passing number of neighbors is equals to I. So the first time this loop will run, the value of neighbor will be 1, and then I will calculate the error rate. Then I will be 2 and I will calculate the error rate. So I will calculate the error rate for 30 different value of nearest neighbor, and I will select that value of nearest neighbor for which the error rate will be minimum. So here I am instantiating, and here I am fitting my classifier to the training component. Here I am getting the prediction, and here I am comparing the prediction with the actual testing label so that I can get the accuracy. Here you can see that I am subtracting accuracy from 1 in order to get the error rate value. And here I am appending the error rate value to the error rate so that I can get the 30 error rate value. So the concept is basically here, the error rate is 1 minus accuracy. If accuracy is 0.9, then the error rate value will be 0.1. So I am instantiating my classifier. I am fitting my classifier to the training component. I am getting, after training the model, I am getting the predictions from the model. Here I am calculating the accuracy, and here I am calculating the value of error rate, and here I am appending the error rate to my list. Okay, let's run this cell. And now it's time to plot these 30 value. Here I am plotting error rate against the 30 value of nearest neighbor. So the color is magenta, the line width is 3. This is my marker, and this is my marker face color, and the marker size is 10. So this is the title, this is the X label, that is number of nearest neighbor, and this is my Y label, that is error rate. Okay, this is very standard stuff. So let's run this cell and see the plot. Okay, this is my error rate plot. So we can see that when the number of nearest neighbor is 1, this is the value of error rate between 0.07 and 0.08. Then it goes up, and then again is starting to go down. So the first time it reached to the minimum value is when the number of nearest neighbor is 15. And then it continue till the value equals to 21 or 22 here. Basically, it seems like it is 21. Okay. Now, the first time we reach to the minimum value of error rate is when the number of nearest neighbor is 15. It means now we are going to select the nearest neighbor is equals to 15. With this value, I am again going to train my KNN model on the same challenging data, and I will see whether the accuracy is improved or not. So you can see here, I am again going to instantiate my KNN classifier. This time, the number of nearest neighbor is 15, and I am calling it KNN underscore 15. Let's run this cell to instantiate the classifier with neighbors is equals to 15. Here I am training my new KNN classifier on the training component, and here I am getting the prediction from the testing component. Let's run this cell. And now I am comparing the prediction of the model with nearest neighbor is equals to 15 to my actual testing sample. Let's run the cell to see the accuracy. So we can see that we have improved the accuracy in a considerable amount, that is by 2.5%. Without selecting the optimal value of K, the accuracy was 92.5%. And after selecting the optimal value of K using error rate plot, our accuracy has improved to 95%. So in this way, we learn it's better to select the optimum value of K using the error rate plot in order to get the best performance from the KNN classifier. Okay, there is another method of finding the value of K or finding the value, optimal value of K using grid search cross validation method. Let's see how this method works. So for this, I am using K is equals to 5. That is the number of split for cross validation is equals to 5. Let's run this cell. And here I am again instantiating my KNN classifier and I am calling it model. Now here I am passing the input parameters to the model so that it can select the best value of the parameter. So there is only one parameter for KNN classifier, which is the most important parameter, that is the number of neighbors. And here I am passing 30 different values from 1 to 30 in the form of list. And here I am training my model. Here I am passing those parameters here in a grid search cross validation. The input is model. Here I am passing the parameter grid, which is the parameters of KNN, that is this value, and my cross validation is equals to CV and the split is 5. So basically I am going to perform grid search cross validation on KNN classifier. For this grid search, I have only one parameter, which is n neighbors, and I am calling it param KN, and here I am passing a grid search function. The first input is a model, then the parameters, and then the cross validation. Here I am fitting this model to the training component so that I can get the best parameter, and here I am observing the best parameter. Let's run this cell to get the best parameter. So grid search CV is saying that the best value of nearest neighbor is 25. From the error rate, we observe that the best value is 15, but grid search cross validation is saying the best value is 25. Okay, let's calculate the prediction when nearest neighbor is 25. Let's run this cell and now compare the prediction of grid search cross validation with the actual label of testing component. Let's run this cell. We can see that our accuracy is 94%. Now this accuracy is 1% less than those classifier or that classifier which is selected by the error rate, but this 94% is still larger than this 92.5% where we did not select the optimal value of K but use the default value of K. So we learned that there are two methods in order to select the optimum value of K, whether we use error rate plot or we use grid search CV. The performance is very close. With error rate plot, we got the 95% accuracy, and with grid search, we got 94% accuracy. Okay, let's create the confusion matrix for accuracy is equals to 95%. That is for the model which was generated by error rate plot. Here are the font values for the confusion matrix. Here I am importing confusion matrix, F1 score, precision, recall, accuracy score, and confusion metric display from sklearn.matrix. And here I am getting the figure or the image of my confusion matrix. So we can see that this is our confusion matrix of 3 classes. So the values along the diagonal of confusion matrix always show the correct classification. So this 5 is a misclassification. This 5 is this 0 are also representing, that is there is no misclassification here. There are 3 misclassified value for this label, which is 1, and there are 2 misclassification here for label equals to 2, and there are 5 misclassification for label is equals to 0. So that's why there are a few misclassified value which are not along the diagonal, they are outside the diagonal of this confusion matrix. The diagonal of the confusion matrix always represent those samples which are classified correctly by the model. So since there are a few classifications, misclassifications, that's why our accuracy has reduced to 95%. Now here we can calculate the precision, recall, and F1 score as well. So you have seen this code many times now in this course. So this is very standard stuff, and we can see that the accuracy is 95%, the precision, recall, and F1 score are also approximately 95%. So student, in this project, you learn how to find the optimal value of K in order to get the best possible performance of KNN classifier. We learned that there are two different methods in order to find the optimal value of K. The first method is using error rate plot, and the second method is using grid search cross validation. So you can use any of the method because the performance of both these methods are very close to each other. So I hope you understood this lecture. I hope you understood this project very well. Thanks for listening, and I will see you in the next lecture.